We'll go over cosmic rays, Galaxy NGC 1275, and more. Welcome to Twitch. Twitch is a great live streaming platform. Twitch.tv/smAsho. Mash is the location. Thanks to our new subscribers over on BitChute. And thanks to our subscribers over on YouTube as well. Wherever you're watching, leave us a comment, press like, press subscribe, press the share button, and tell your friends, foes, science noobs, and science pros about the content. So today's cosmology segment is going to start out with the first flight of an aircraft on an alien world. So today's astronomy picture of the day is actually a video. And it is a video of the Mars Ingenuity helicopter taking flight on the red planet. Let's go to full screen for this. It's not going to go full screen. Anyway, there is the view of that. There it is, the first flight of an aircraft by mankind on an alien world. It does a little rotation. It hovers. It sets back down. Good times. If you want to check out the astronomy photo of the day, it's apod.nasa.gov. And there it is setting down. Rather hard, but nonetheless, all systems are go. Next, let's look at cosmic rays. Here are two monitors, the Apatity and Barentsburg neutron monitor. So you can see at Apatity a precipitous downtick here over the past 30 days. Significant downward trend at Apatity in cosmic ray flux. Similar downward trend at Barentsburg, rather, as the solar toroidal field increases in its power. Next, looking a little farther south at the Athens, Greece neutron monitor. Slight downward trend there at Athens as well. Let's go even farther south to Mexico City, which is actually pretty flat here over the past 30 days. And also here is Oulu, Finland. Oulu, Finland, pretty flat over the past 30 days. Let's check DOMB, Antarctica. DOMB, Antarctica, flat over the past 30. DOMC, Antarctica, similar to DOMB, just with a tighter range. Now, today we're not picking a random number. We're looking at Galaxy NGC 1275 and one of its jets. So this is actually Galaxy NGC 1275's gamma ray production. This is the Fermi scope here on Aladdin Light. And we're going to show you also the Chandra, as there is a very detailed image from the Chandra X-ray observatory. There you can see all of these structures here in X-ray. Fantastic view from Chandra. And we'll also take a look at Pan-STARRS. Great view of 3C84, one of the jets associated with Galaxy NGC 1275. Why? Well, because there's some research into this jet, as galactic-scale jets are a very important laboratory by which to understand, well, astrophysics, cosmology, etc. And so these things emit radio waves, they emit gamma rays sometimes, various aspects of the electromagnetic spectrum. They're also emitting particles. And what happens, folks, is the particles come out of the polar fields and they smash into other material associated with the jet, and those collisions produce gamma rays. This article is on phys.org in the Astronomy and Space section. Research investigates radio galaxy 3C84, one of the jet portion moments of Galaxy NGC 1275. Now, what's going on with these things? So here's the jet. This is a close-up of the jet. And all of these objects precess, folks. So all rotating objects in the universe precess. And when these things precess, sometimes they're more aligned with their magnetic fields than other times. So let's just say at the center of this precessional wobble here, let's say the magnetic field is oriented in this sort of a direction. These things are going to output more material when they're aligned with it than when they're not aligned with it. So when the output is aligned with the magnetic field, we see stronger outputs from the jet and weaker outputs from the jet when they're not aligned. When they are aligned, that's when you're expecting to see these gamma ray burst moments happen, when those strong, powerful outputs. So these things are always putting out protons, folks. Most likely, there's a stream of protons coming out of the poles of these objects. And again, when they align with the fields, those are the moments when we see the most powerful outputs from them. And there is a relationship between this, the toroidal field, and this, the poloidal fields of all of these objects. And I won't go further in depth into that today. Let's talk about dust, as dust is in the news as well. Here at the Smash News Network, we're very interested in dust because, well, dust is kind of important, as the mechanisms behind which stars and planets and so on form is not understood. And here at the Smash News Network, we prefer to help people to understand things a little better. So what we're looking at here is the WHISPER instrument from the Parker Solar Probe. And the Parker Solar Probe is the fastest object ever built by mankind as far as we know. And what we're looking at here is Earth. That's Earth right there. Here's Venus, and here's Mars. And what this is right here, let me just get rid of these. What this is right here, this is Venus's dust lane. Yes, there is a dust lane on the orbit of Venus. And the Parker Solar Probe just got great imagery of it. This article here, another article on phys.org's Astronomy and Space section, the complete view of Venus's orbital dust ring. Now, sometimes Earth's dust ring is visible from Earth. That's known as zodiacal light. You can see this coming up sometimes if you have a good view and low amount of light pollution at nighttime. You can see the Earth's zodiacal dust. And that brings me to an important point about cosmology. Yes, cosmology. Now, what you're looking at here, these are glass beads in microgravity. And how come they're forming into these long strings, folks? And the reason is polarization. Polarization caused these glass beads to form into these long strings. Gravity wasn't required, just their polarization caused them to stick together. So when these objects get close enough to each other, they align into the same magnetic spin moment, we'll call it, and this causes them to stick together. So this may be the missing link between gravity and how objects form. So at a smaller scale, perhaps objects stick together like this before they aggregate into a larger object big enough to produce enough gravity to make them stick together on a larger scale. This article is entitled, "Physicists May Have Just Solved a Fundamental Problem, a Fundamental Mystery of How Planets Form." And we covered this probably the day or maybe the day after it came out back in 2019. I just wanted to revisit it as we talked about Venus's dust lane and the relationship to cosmology. That's today's cosmology segment. Thanks for tuning in, folks. And we'll have to say goodbye to Twitch. Bye, Twitch.